Oh, hello. Didn't see you there. Do you wanna do a brushless ESC on Solidworks? Well, you're in luck. That's what we're doing today. So let's go. I don't know why would I do my intro there. We've already done a whole video. I can put that at the beginning, I guess. Hello everyone, welcome back. So last time we went through and I talked incompetently and in a very uneducated way about the Maytech motor. We had our first look at the brushless motors. We modelled up the outrunner so that we had some CAD to use. We're going to be doing some testing on it and we're going to test it against the brushed equivalent or the brushed alternative next week. But what I'm going to do today is we're going to go through and I'm going to do the same for its friend, the ESC. So this is the 100 amp speed controller that is the recommended choice for the Maytech outrunner. Okay, so this is the first time out the box. So ooh, it's very, very nice, very shiny. Comes with a on-off switch, so I guess that this is, if they use it for a electric skateboard, this will be the control. So there's probably programs you can do where you do multiple things or whatever. Obviously we're not going to use that, so there's a wire here which probably goes in one of these. That might be the one for the hauler, the sensor actually. Grubber motor. This is the guy we done last week. Yeah, so that must go straight onto there. And then into here, I guess. Yeah. And then they come pre-terminated, so we can go put our, there's the 8mm bullet connectors straight in there. And we've got our power in there, our receiver wire there, and that's good to go, I guess, after maybe some programming. What's this? Yeah. Program wire, is that a, of course, they give you a free phone charger. So that's quite good because the VESC BB needs a really weird wire and I had to go out and buy one. And it took me ages to find out what one it is because they don't make it very easy. And then you have to then power it separately. So hopefully this will work if you just plug it in because this is a 5 voltage supply to it as well. Like, I'm happy to take the thing apart, but I have no idea what I'm looking at. So I'll take it apart. I'll do some nice shots of it for you, and then if you can have a look. Maybe there's some stuff that are rattle free, so maybe it will be of some benefit to us. Before we take it apart, let's just have a look at what we can see. These are some nice big capacitors or something. I have no idea. And this is quite cool. This is it's a heatsink in here, so this is going to be an aluminium housing, I'm guessing, to wick away the heat. Yes, yes, yes. Not. Oh, what's that? Oh, it's the bolt. Cool. Right, well, let's have a look anyway. Yeah. Let's void that warranty. I don't know if you get a warranty on these. I'd imagine you do. They seem like they're pretty good. But I don't know how that would work. I guess you'd have to ship it back to China. At the point you put stuff into a fighting robot, usually you don't get much of a warranty with any of the stuff you buy, to be honest. I think they count that as abuse. The suspense is killing me. I'm so excited to get into this box of. I guess we could do a model of the whole casing, and then if we wanted to, we could machine it into the side of our robot, like into the chassis, and just have these mounted directly on the chassis. That would be cool, huh? I'm not going to do that. So here we go. What are we looking at? Is that solid? Yeah, okay. That's quite nice. They've epoxied the wires in place so they don't move about. That's quite useful for us. Maytech brand board, so at least they make their own stuff. These just look like so comically oversized compared to all the other components. Wonder what they are. Don't seem to want to come out. I can't see any mounting holes there. Oh, we're going. Oh, no, it's stuck. Oh, there we go. So it's pressed into this gunk there, which is just to transfer the heat to the heatsink, I guess. Then we got all our, I think these are FETs, which are the things that do the switching. So we got one for each phase, two for each phase. Some big heat sinks there to take the heat away from whatever component they're attached to. I don't know what I'm talking about at all. They do have some sort of form of quality control in the factory. That's quite nice to see. And then nice big healthy dollops of solder. So there you go. I can't be much help here, I'm afraid. Someone must be enjoying this, right? Just statistically, the amount of people that exist in the world, someone must want to watch this. So that's why we do this. We're aiming for that tiny percentile of people that are turned on by the inside of speed controllers. There we go. I don't know what I'm looking at, so I'm just going to put this back together. That really is nice machining. This is all CNC'd out of one piece of billet. Like I thought it might be a casting. Like it's crazy the detail in there. Look at this. There's a little step on there, so you get positive registration with the other end. And again, this is all CNC'd as well. I thought this might be a casting. You can see this part here. I thought that might be a casting mark, but I don't think it is. Aluminium. Again, is it anodized? Yeah. I'm gonna have to say it's very, very nicely done. It fits on there real nice. That's a real, yeah. Okay. I've got to try and line all these grommets up now because I shouldn't have took it apart. Press this down real nice. Oh, it's upside down. That's not going to help. As long as I get this one lined up on the top, the bolt should pull it home anyway. There we go. Look at that. Tiny bolts. What size are they? M2. Machining to get an M2 tap and a little tiny piece like that. That's obscene. How do they do it? Right, well, I'm not as knowledgeable about that one, I'm afraid. One thing I was worried about is these things shaking loose, but as we saw as we took it apart, they actually extend about here. So they're fixed in on this point there to the actual circuit board, and then they come in contact with the casing here. That's quite a tight fit on there, so I'm not so worried about that now. So it was worth taking it apart, definitely. Same with all the wires. They're all held in place with these little grommets, which have got an interference fit. They get squashed up as you do up this casing. As long as it performs now, I think that this is some really good quality stuff. I was trying to come into this not biased, but to be honest, I kind of wanted it to be a bit rubbish because there's going to be a lot of work to figure out how to use them. And I kind of wanted to stick with just the brushless one, so maybe if I saw this and it was rubbish. Credit where it's due, it's quite well made. Right, well, let's get a model of it and then we'll run through the software, I guess. This is the first time I've run the software. I haven't installed it yet because I just wanted to show you this thing that comes up. Things that can happen even when using the correct settings are electrical failure, fire, electric shock, hazardous smoke, overheating. Firmware can only be used by experts and experienced users who know exactly what they're doing. I understand, so there you go, we might go on fire, and that's even when using it correctly, so I don't know what chance we stand. I think this is just a open, what do they call it? Open source program. So I don't, this is the one Maytech use, but this obviously isn't their software. So we're plugged in. So do you have to power the VESC as well? That's annoying. I want to go get a power supply. Can't find it! Right, well, can't find my power supply, but I did find this, which is a 5 volt, 12 volt adapter. So I think I should be good because I can put 12 volts into that easy. Put it over there. Just going to cover that up so I don't accidentally short. And then I should be alright, shouldn't it? Help! I don't know what any of this is. Hello everyone, this is Future Tom talking. I thought I'd go back and have another go at this now that I've actually used the program and know what I'm doing a little bit better. So what I've got is my power supply set up on my bench with the ESC attached to plug straight into the motor, and we're going to connect to this ESC tool and it should connect. Is it? No, it's not. Device manager. Let's see what's plugged in. COM5. Right. Okay, and we're connected. Yeah! I'm still no expert on this, but if we go through the motor setup wizard, that'll at least enable me to set it up so that I could actually run my test with it. So if we go into this, blah, 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 update the firmware. Yeah, sure. Do you want to continue? Yeah, sure. Gotta wait 10 seconds. Oh no, okay. Oh no, it didn't like that, did it? Now we get. Oh God, what is happening? Now we're connected. Okay, let's just run through this. So motor type, we are a brushless DC motor. Cool. So there is an option for DC there. I think you can run these as a brushed option as well. And FOC, I don't know what that is, so we're just going to ignore it. You're about to configure current limits. Bear in mind, too high current limits, we set our motors on fire. Cool. So current limits, I'm going to leave that as is. So these, I think the motors are rated to 80. The ESC is rated to 80 continuous. I'm going to leave it at 60, so we're going to go a little bit conservative. This was the only values, by the way, that I could make that made a real difference with the start torque of the motor. So messing with these, but obviously then you're putting your ESC at more risk. Battery cutoff voltage from to prevent over discharging, sure, but we're using a power supply now, but this just saves your lipos going too low. If you discharge them till they're absolutely empty, they die. Right, then we're running censored. We've got no sensors or sensors. Let's go censored. There's a bunch of settings here and I don't know what this is, so I'm going to ignore it. I come down here and there's a fun thing you can do where you press this and it spins the motor. Oh, well, I guess a power supply didn't like doing that. Put the ampage button. There you go. Done it. So that I only have 5 amp supply on my power supply, so I just maxed it out, and I guess it took 5 amps because it read the hall sensors and it gives you a bunch of values there. So we go next on that, and then we're finished. So now I'm pretty sure we should be able to control the motor with our mouse. It's going. It does that as well, only it spins better in one way than the other. I'm not quite sure how you fix that. There's tons and tons of settings. So there are a bunch of settings here and I kind of played around with all of them. I kind of have a better understanding of it, but not really. So there are different ways you can run. This is like a different control method, so you can run through and do a test for this as well. So we click this and it fills in all these values. And then we click this one and it runs another test. And it fills in the rest of the values, and then you apply it here and it flashes it across to the motor, and I think then it changes the way it operates. Go back to our keyboard. So that's just, it's a different control method. There's a bunch of stuff in here and I'm not quite sure what all of it is. But in this app settings one, we've got another wizard we can run. So if we go through and do that, we go next.
Would you like to load the default? Yeah, sure.
So my setup has a single VSC, it does. You can put an input through a RC signal. So here's there's ppm pulse length mapping, which I think is different control methods again. So you can either control it with the current, so it measures the current coming in and out, or you can measure the duty cycle, which I think measures the speed, or PID speaker. I don't know what any of this is. So maybe duty cycle is the load, but then surely that's the current as well. Anyway, I messed around with all of these and I could get the current to work pretty well. That would work forwards and backwards on the RC thing. The duty cycle was a bit more hit and miss, and this one I didn't really have much success with. So I did notice as you press up and down on the RC stick, these values change. And this one's the middle, that would be the sort of resting center of your RC stick. Because we haven't got the RC thing set up, I guess we can't do any of this. And then okay, and here's some more stuff. So this is the same as the last menu. I really don't know what I'm doing, do I? Yeah, I just tried a bunch of stuff until it worked. I just done a lot of trial and error. Sometimes the motor would just go like and won't work at all. Then you can flash them all through anyway to the ESC. So let's do it on the duty cycle, see what happens. Actually, we can do some real-time data analysis. If we look at this, if I spin the motor now, it gives you real-time data, which is quite cool. So that's our back current. So I'm powering the motor there. Let's do the keyboard controls again. So I'm just going to press the buttons. Oh. And it does a pretty good job of monitoring what's happening. Oh wow. I just noticed there's a... Oh wow! That is quick. That's running at 12 volts. That was pretty... I just realised that up and down gives you the... This must be like stepping. And this is like this is to pulse it. So yeah, it does a pretty good job of monitoring what's going on. Let's change our control type to PID speed control. Just mashing on the keys, seeing what I have. So yeah, that's quite fun. One thing I did notice that's pretty nice about this speed control is it does a really nice job of monitoring the current going in. So if I now hold this motor, so I'm not going to let it move, and I'm just going to press go, manual throttle control. And if we just watch the current on there, so I've got this limited to the 5 amp, which is the maximum this can supply. And even at full stall, you see that it doesn't really jump that much. It recognizes very quickly that it's stalled. I could sit all day and I don't think it'd damage any of the components. Which I can't imagine doing this on a brush controller. Like I'd be on fire right now. Ooh. Oh, that was quite cool. So at lower speeds, there's way more torque and it was pulling more current. Oh, there's so much I don't know. Go up to 3 then. Even then, see, like it just shuts off. It doesn't hurt itself. Like I'd be able to feel if this was getting hot, and it isn't. Let's put that back before we break it. Oh, this is quite nice as well. This, if you press this, it enables the electric braking. You can actually feel the motor have a lot more resistance. And I think you can change the settings for the braking up in the, they'll probably be in the app settings. Brake current, yeah, here you go. So maybe it's in here. Anyway, so I thought I'd just share some of the stuff I learned about the program. That's enough. Back to the video. Right, so we've got a bunch of stuff on here. I don't know what any of this will do. The USB is important though, because we want to avoid that. 100 amp VESC. So, Solidworks. Right, so we just come to a new part, and this is a square part, so it's going to be an extrude. So as a general rule, if it's a turned part, it's going to be a revolve, and if it's a milled part, it's going to be an extruded square bit. So let's start there. So let's do this on the top plane like that. I'm even looking at the right dimensions, that's not going to help. There we go. This was... Oh, I'm gonna have to go get my calipers now. Left them in the garage, didn't I? You wait there. Freezing. I'll probably edit that bit out. I probably won't actually make you wait. Like, I can't imagine your patience will stretch that far. I'm probably already on thin ice. Continuity. I've just got to whack a bunch of these wires on now just to check that I leave clearance. Oh, and the ports on the side to make sure I leave access to them as well. It's quite annoying. They put the sensor wire on this side and then the power wire to go to your laptop on the other side. You need to leave it so you can get into both sides. It's a small thing, I guess. Still. Do I have to do it? Yeah. That's about right. There's a little chamfer up on top as well. I'm going to put that in because it'll look nice. Wonderful. Right, so let's put these ones in as well, just because. And the most important thing possibly, there we go, is change our, I can't do two things at once, is change our mass properties. So we weighed it, did we weigh it? Of course we didn't. 174. That is light. That is light. And there we have it. That is our finished model. That is as far as I'm going to go with it because I'm not making it any more intricate than that. I'm just wasting my time. I've already got to design a whole robot. I don't want to spend my time designing a whole speed controller as well, alright? Okay, I'm going to throw this up on my website, Tom Code Designs. It will be in the download section if you would like to have it for yourself, like maybe collect them. Save that as a step and as a power solid then. Then everyone can use it. If you like this video,